Good afternoon, YouTube. I'm Greg from Greg's Tutoring back here again. How is everybody doing? So we're up to part 12 of the SHSAT-like ISEE questions. So we're kind of beating this to death. It's been an interesting journey. So let's just continue on. Please like and subscribe. And let's see where we can go here. So the last question we did was 14. So let's try 15. Let me see that the screen is still going. I'm going to go maybe half an hour to 45 minutes here. Most likely, probably I'm going to end up going longer. I always end up going longer than I think I am going to. All right, so that is not showing on the screen. Give me 1 second. It's cut off. All right, there we go. I believe. Give me 1 more second again, because it's not sure if the video died or not. All right, there we go. So 15, what is the maximum value for y if y equals 2 to the x squared plus 1? For minus 2 is less than or equal to x is less than or equal to 1. So we got this ugly equation here, or whatever you want to call it. And what are we going to do with it? Y equals 2x squared plus 1. And they're giving us a range that x is between minus 2 and 1. So all we really need to do is plug in the x here and see what the ranges are. So let's do the extremes. So we have y equals 2 times minus 1. Sorry, that's a 2. 2 times minus 2 squared plus 1. It's important that this negative has to be retained here. So we get 2 times 2 plus 1. So we get 4 plus 1 equals, we get 5 when it's minus 1. So minus 1 gives us 5 for y. If we go to the other extreme, which is 1, then we get 2 times 1 squared, which is 1, plus 1. So we get 3. And I don't get the answer. I don't have, what is the maximum value allowed for y? $15 is coming up as 9. Yeah, I left out the multiply by 2 here. I said 2 times 2. Minus 2 times minus 2 is 4. 4 times 2 is 8, plus 1 is 9. All right, so the answer is C, 9. Made a mistake there. Watch out, people. By the way, I mentioned that a lot of kids lose points on the silly errors. I also have mild dyslexia. That did not come into play in this case. It just blew out of my mind that I wrote this down sloppily. So be careful. And also have a way to check your answers that's the case, because you could do it a second time. So I was worried so much about telling you guys to maintain the integrity of the minus sign that I forgot the extra 2 there. All right, so that's important. All right, so we get 9 versus 3 and 9 rules. So it's just a matter of plugging it in and going with it. Okay, 16 is an ugly problem, period. Let me just make sure it's showing on your screen. All right, there we go. So if f of x equals x squared and g of x equals x squared, which inequality is true? So this blows a few kids' minds on a few levels. The first is that this terminology of f of x equals something. Some kids don't know what that means. You're supposed to by this point. So if you don't, go back and look this stuff up. But one easy way to remember it is that make believe this is y. So if it said f of x equals 2x plus 1, then y is equal to 2x plus 1. Okay? That's the first thing. So it's just an equation. This is saying there's a function here. We input x, right? Normally we input x, and our output is y. Right? So normally we might say if x is 1, then y is 3. It's what I just did in the previous example. So this means the same thing. So when I put f of x equals 2x plus 1, and I say x equals 5, it means replace it here. And everywhere it sees an x, it's going to put that 5 and get 11 in this case. 5 times 2 plus 1 is 11. All right? So this example is going to mean the same kind of thing. So if I say f of x equals the square root of x, then if I said f of 9, I'm talking about the square root of 9. And I get plus or minus 3, right? By the way, depending on which test you have, some tests do not care that you use the minus sign. So plus 3 is an acceptable answer in enough tests. Okay? So that's what's happening there. And now what the deal is with the g of x? Well, the g of x works the same way. So if I said g of 9, that's equal to 9 squared, or 81. And I can loop this. I can say something like the f of the g of 3. So if I did g of 3, that means 9, and that gets replaced by 9. So now I have f of 9. I come back here and get the square root of x, and I end up back with 3. So I use the two functions recursively, so to speak. All right? So let me get a blank page here, because this is ugly stuff. And let's try to see if we see any patterns here. So it's doing f of 0.9 a whole bunch of times. It's also doing f of 1.1. Is that the only two cases? It's also doing g of 0.9 and g of 1.1. And those are the four scenarios. And then it's going to try to compare and rank all those. So if the f is the square root of x, f of x, I should write it properly, and the g of x is equal to the x squared. So we can do the g's easy enough. So we get 0.9 times 0.9. And we get 8.1, we get 0.81. And g of this, so if you remember, I talked to you guys about making sure you know your squares table. This is basically 11 times 11. So we get 121, and we move the decimal point over twice. So this is equal to 1.21. So we have those figured out already. So the question is now, what is the square root of 0.9? A lot of kids are going to write 0.3. But that's not the case, because 0.3 times 0.3 gives us 9, and we move the decimal over twice. So that's 0.09. So this is not true. So what is that? Well, this is close to 1, so the answer is close to 1. Because if we already saw with 0.9 twice, we get 0.81. And if it goes to 1, we get 1. So it's somewhere between 0.95 and 1. Okay, so f of 0.9 is about 0.9. Okay, and what about the square root of this? And again, you don't have a calculator in a lot of these tests, especially the SHSAT. So what is the square root of 1.1? Well, you have to know it's greater than 1 for starters. If it's 2, this is already 4. So it's something very close to 1. So it's about 1 point something. And probably the low somethings. So is that enough to answer this? I'm not sure yet. So let's try to run through the scenarios and see if we need to get anything closer or not. Okay, so the first one says f of this 0.95 is less than that, which is true. So A is still good. Is less than this? No, this is smaller. So we know the G of 0.9 is lower than the both of these. So that rules out A and C, and we're left with B and D. Okay? So B says 0.81 is less than that. That's true. Is less than this is true. Is less than G of 1.1. Okay, B looks true-ish, if I just round through that right. And D says G of 0.9, 0.81, is less than G of, wait, where are we? Of less than F of 1, it's true, is less than F of 0.9. Okay, D fails that. So the answer would be B. So we did this without even getting the numbers exactly. We just got very close and we tried to make number sense out of it. Number sense. So what we did was we calculated the numbers we could exactly, and we gave an estimate to the ones we didn't. And I put this little tilde here, meaning kind of. See, I used it here, and I used it here, or whatever it was, the first one. So I'm kind of giving myself a heads up that if I couldn't figure it out from B and D, I would probably have to go deeper here and make it 1.0 something or 1.1 or whatever the case may be. All right? So by the way, as you can see, we're starting to get deeper in a lot of these things. Some ugly mess stuff. All right? So again, if you didn't follow this, stop the video, go back and replay it. Try to do it yourself. See where your errors are going to be. This is an exact kind of question where everybody knows how to square a number and everybody knows how to get the square root of a number. And if you didn't know what functions mean, go look those up. But now that you do, that's basically all you need to know about functions to do this, was to just plug in the numbers they gave and sort the numbers. And don't get caught up in stuff like the square root of 9 is 3, therefore the square root of 0.9 is 0.3. It's just not true. Okay? And again, know your squares. So there's a lot of little subjects happening in here, 4 or 5 little subtopics happening simultaneously. I am so hot, people. By the way, if anybody has any guesses or wants to try the problems while I'm doing them, please, by all means, do so. Okay, 17. Let me see if I can get that fitting on the screen. I will move this over here. And if you're not sure of a question, you can always email me on it, and I could explain it better in email, or maybe even do another stream which further expounds on what the heck is going on here with some of the concepts. Again, there's 4 or 5 concepts here, and I'm covering it fast. And again, on the real test, you have about a minute and a half to get this yourself. So you want to prep and you want to understand all these little subtopics. I just did another stream which I ended because it's overwhelming. It can be. And what you want to do is prep and study and go through this methodically and calmly, so on test day, you're okay. And if you need to skip a question that's too hard, skip the question. Come back to it later, make an educated guess. Even if you can't figure it out, that's the end of the story. Some tests are made to not be finished. Okay, something like the SHSAT is one of those tests. All right. Okay, so let's do the next question. John and Aaron were both jogging on the same path. So again, I use the same procedure here. I take this a sentence at a time. I don't move on to the next sentence until I understand the first sentence. When I finally understand the first sentence, and I do apply phrases, so within a sentence, if I don't understand the whole sentence, I break it down into phrases, and I build it up as I understand each phrase. And as I build it up and understand it, I ask myself questions about it. Once I get past the first sentence, then I go to the second one. Once I get to the second one, I break it down and understand that, and then merge the two of them and try to make a super understanding of it. And I'll keep going through the word paragraph the same way. If there's an illustration, I'll look at it first. Okay? I'll start writing down the givens of the problem. I will see if there's any equation I'm supposed to know, things like that. Okay? And you also have to realize in some questions, and I think that was the case with this one, if you notice A, B, C, and D here, they're not looking for a numeric answer, even though you may have to compute a numeric answer to do that. Sometimes they're just trying to look for your number sense. Again, I used that term in the previous example. It's still on the screen. They're just trying to understand, do you understand the math here enough to understand the question to be able to answer it without giving an exact number, with giving an estimate, yada, yada, okay? So John and Aaron were both jogging on the same path. Cool, they're both jogging. Each at a constant speed, so they're both going at the same rate, 50 miles per hour, whatever the case may be. And Aaron at a faster pace than John. So they're both each going at an individual speed. Make sure that's clear to you. It doesn't say, for instance, they're both running at 10 miles per hour. It may end up being the case that they are, but it's the case that Aaron might be going 20 miles per hour and stays constant at 20. And John's running at 10 and stays constant at 10. Okay? And if she runs at 20, she's a pretty good runner. Because I don't know that a human can do that. But in any event, so when Aaron starts jogging, John has jogged 500 meters. So John starts here. He goes 500 meters. And this is the point where Aaron starts jogging. When Aaron starts jogging, John has already jogged 500 meters. So we don't know if she's doing it there or not. So which one additional piece of information in meters per minute would be needed to determine how long in minutes Aaron... Okay, so she doesn't start here because they're talking about once she catches up. So when John is here, that's when Aaron starts. Aaron starts when he's run this thing. So it might be, X minutes later. And then it says at some point later, they want X, is that? They go another Y, or certainly John goes another Y. She still has to run the X and the Y. At some point, both Aaron and John are at the same point. So that's what the question is. So run through it again. John and Aaron were both jogging on the same path, each at a constant speed. And Aaron at faster than John's speed. So we know that John, let's say he was going 10 meters a minute. So Aaron might be going 11 meters a minute. Okay? So when Aaron started jogging, John had jogged 500 meters in meters per minute, which would be needed to determine how long in minutes Aaron had been jogging when she caught up with John. So, do we need to know John's speed? Yeah, that would be helpful, but that's not going to determine how long. Do we need to know Aaron's speed? Yeah, we do, but not just Aaron's speed, okay? We need both of their speeds. Do we need the sum of their speeds? Well, think it through logically. Do we need his speed plus her speed? We're trying to find out what happens here with John while she's still trying to traverse the whole route. So just logically, the sum of their speeds doesn't really help us. Because we're trying to find out how she catches up to him. So we need the difference of their speeds. So 17 would be D. Yep. So this is just a logic thing. It's the difference in their speeds. Because once we know the difference in their speeds, we can calculate John's thing here and her thing to catch up after the 500. And it all works out. And they lived happily ever after. All right? So we don't even need to actually do a calculation here. It'd be a different story if they asked us that. If they ask us that, we cannot solve it because we don't know their speeds. Although we can make up a hypothetical speed. I think 17 is B. Where's 17? Oh, we're doing 17. Well, it says which one piece of additional info. So we just can't have Aaron's speed. We need both of their speeds. We need both of their speeds. Not just Aaron's speed. Both of their speeds. So that rules out A and B. So the question is, are we adding them or subtracting them? Okay? And it says additional info. So the additional info that you can either give us or we have to calculate it. By the way, that's why this is a good question. It's tricky. In fact, I think I was looking on this on my phone the first time I ever saw it on the E-Train. And I believe I got it wrong, trying to use the E-Train as an excuse. I think I answered C when it bugged me, and when I got home, I tried to calculate, and I was like, no. It can't be the sum of the two of them. All right, so 18. All right, 18 is a visual one, which if you're doing the ISEE, it matters. Let's see, how can I squish this down? Let me make it smaller. Is that too small? Let me try to make it a little bigger again. And I think I just crashed my my preview program. Give me 1 second, people. Yep, the viewer crashed. Give me 1 second. I will reload it. It's displaying on your guys' screen, but it's actually not, doesn't exist anymore. So give me 1 more second. Yeah, I just saw it flick off. Okay. I don't know if it's going to pop up back automatically or not. Let's see how this works. I don't know why the stupid thing does that, but so be it. All right, this is 18, 1. Yeah, I'm not sure we're going to get that to fit. Let me see. All right, let me get rid of this thing. There we go. All right, it should be showing on your guys' screen now. Okay, so the question is, which figure is a possible net for the cube? So basically they're asking us, which of these can we overlay on top of the cube? And it will do it as a trace pattern. I just lost my pen. Okay, so this is a matter of being topological. By the way, on a test, you're allowed to rotate the paper. Some people can do this turning in their head, and some people actually cannot do the topological cognitively. They have to do it physically. So, in other words, take your test paper and turn it. If you need to turn it upside down, do that. Some people also, when there's an optical illusion, they cannot figure it out until it's upside down or turned in some way. I don't recommend ripping your paper. There are some cases where some of these problems work out if you fold it, okay? But in this case, turning it upside down may or may not help you, But what you might be able to do is turn it upside down. Once you turn it upside down, redraw the cube with X. I'm going to put X, Y, and Z here for the different shapes. And then bring the page back to normal, and then see if you can map it on the upside down view. Because sometimes that's what you need to do. You need to map something upside down or not. So let's just run through some of the scenarios here. And like I said, some of you guys can join in here and guess. And I'm going to decide, let's see, how long is the stream going for? 38 minutes. Let's go a few more minutes and see where we end up. I'll try to finish the section. I think there's 2 or 3 more questions to it. If not, we'll decide from there. So if you notice, what they're showing is a cube, right? There's 6 sides to it, and they're showing 3 sides. All right. So what you have to do is take the 3 sides they give you and unravel the cube. In other words, open it up as if it was A, B, C, or D, and find out which of those matches it. Well, for some of them, you can't tell on the bottom of the T part here. So on some of them, this area here is not what's showing. Okay? Because, say for D and C, there's no triangle. In fact, there's no triangle on A, B, C, or D at the bottom part here. There's only triangles on this part here. So what you have to do is start figuring it out if you unravel it. And by the way, if we use this X, Y, and Z thing, this cube right here, I'm going to call it C. This cube C could be either one of these 3. So we have a side here we unravel, we don't know what it is. The bottom we unravel, we don't know what it is. And the back we unravel, we don't know what that is. So what we have to do is move the C to where X is and unravel. Move to Y is and unravel. Move it where Z is and unravel. And when we're doing that, we have to make sure the orientation of the triangles maintain themselves. All right? So, for instance, if we take B, B has 3 triangles oriented the same way. Okay? Now, there's a circle next to the 2 triangles no matter how they're oriented. So that just rules out that B is not possible. Okay? D has 3 triangles in a row with a circle next to it. All right? But if we turn D upside down so that we orient the middle triangle on D to the front triangle of the cube, we see that the next one up, if we go up, we're going to get a circle. But if we go right, we have a triangle pointing upside down. But if D we turned upside down, then the triangle on D should be the other way. So D is no good if I'm doing this problem right. What question is this? Okay, so B and A have the triangles alternating their orientation, and what we see in the cube is that the triangles do alternate their orientation. We also note again that the orientation of the one triangle, depending on which we use as the center one, is pointing at a circle. Well, on C, if we go to the first one up, that's not the bar along the top, where it shows a square, okay? So that's not a circle. It's also the other orientation of the triangle. So that means if we use the bottom part of C, if we unravel the bottom part of C around to the top of it, that means the triangle pointing up in the middle should be pointing at a circle as it does on the right-hand side of the cube, but it doesn't. So that's no good. So far we ruled out B, C, and D. So let's make sure A works. Okay? So again, A has alternating triangles, because that's what we see on the front and the right-hand side of the cube. So that's good. We have a triangle pointing up on the right-hand side of the cube, that points to a circle. So we have a triangle on A pointing down at the circle. If we turn A upside down, that's cool. So the question is, the triangle on the front, that's the same as the triangle on the right-hand side of the top of A, because we turned A upside down. So that's good. So there, we just proved that the three that we see on the cube is the first, the two center ones and the right one. So A jives. All right, so this is an annoying one. Again, if you're not good with visual space stuff, wait, how do you know whether the other like shape is on the side of it? You don't know. Let me go back to the question for 1 second. It says, which figure is a possible net? So B, C, and D can't be possible just because of the orientations. So on A, here, we have what, 4? And we have 2. So on A, this, and this all match. So that means the others we don't know if they match. But it says which figure is a possible. But on B, C, and D, we didn't get any match at all. It either violated a triangle by having them that way, or if they were the right orientation, there was not a circle in the right place. In them, there were squares. So this is a tricky one. Again, here, what you need to do is, let me turn my computer upside down for 1 second, because I'm going to do the cube upside down. Because you can do this with your test paper. Turn your test paper upside down. Draw the diagram. Okay? And then turn your test paper back around. Don't turn your scrap paper upside down. Turn your test paper back around. Now try to find which one matches it. Okay? So you can see in A, that this is this way, this is this way, and this is this way. All right? So if this is this, that means the one next to it has got to be that. And the one below this one has to be an O. And it is. We don't know about the other ones. Okay, they didn't give us those. Or they gave it to us, but we don't know it. So it becomes a possible match. And this was so easy to do just by turning your test paper over and copying this. Okay? And it's a way to double check, because even if you can turn it around on your head, I'm able to do that. And by the way, this is a slight advantage to males. Most males, the average male is more visibly and spatially oriented than the average female. Okay, this is not a guarantee. It's not an absolute. There's certainly a lot of guys who can't do it, and a lot of women who can. All right. So, but either way, double check it. Try to double check it. By the way, this kind of question will not come up in the SHSAT, or at least it normally hasn't in the standard in past years. Okay, this is another section. Let's see, how long have we gone here? Let me drag this thing back over. Oh, by the way, was that not even showing before? Anyway, maybe run 2 YouTubes catching this. I think this fell off the screen while I was trying to explain the previous example. Let me just scroll it backwards for a second again. Because since A is the answer, again, I turned the cube upside down. That's what the top is showing. I turned the paper upside down, drew the cube, put the paper back to the way it was, and then tried to see which answer mapped on it. You guys do the same. All right? This tends to be more IQ-ish. It's debatable. Some people debate that something like the SHSAT or the SAT are not IQ tests. They're not standard IQ tests, that's for sure, and they're actually measuring something different. So I will buy that they're not. All right, why don't we do one or two more? Let's try to get to 5:30 and see where we end up. So this is different. The SHSAT will not have questions in this kind of form where it's showing this here. But the general spirit is the same, where sometimes we don't actually have to do a calculation. For instance, if you see a 19, they're already giving you column B. In some cases, you actually do have to do the computations. At the end of the day, it's still asking about the same math. It's just twisting the perspective and the point of view where you have to answer it through, or from, or to, or with, or yada, yada, yada. Okay, I'm beating this to death. All right, let me just make sure the stream, I got it lined up right. Yep, it's good. Column A says 5 plus 2 times paren, 4 plus 3 close paren. So this is really talking about PEMDAS. As most of us like to call it. Formally, it is the order of operations and the unary operators, the binary operators, and how everything interacts when you have an expression presented to you. By the way, is when you guys do, if anybody's into programming, some of the PEMDAS rules are different. The order of operations and precedence and things like that. We call them different things through normal schooling years. So let's just stick with the slang of calling it PEMDAS. PEMDAS says to do multiplication and division first, and then do addition and subtraction. It also says to do parenthesis first. So we're going to do the 4 plus 3 first. We're going to get 7. And then it says do multiplication and division first. From left to right, that's the precedence. So we're going to have 4 plus 3 is 7. 7 times 2 is 14. And we're left with addition and subtraction. In this case, just addition. And we're going to do that left from right. So we get 5 plus 14 is 19. It's 7, 4, yeah, 19. So 19 should be C, because we get 19 equal to 19. Okay? 20. Okay, 20 is a cute one. It's a standard kind of question on this stuff, especially at this level. You won't see this at the lower or the middle level. Actually, sometimes you might see it at the level where they're comparing perimeter and area, but this is throwing algebra into it as well. All right? Okay, so we're going to still approach this the same way. We're going to look at the illustration first. In this case, that's what it gives us first. We're also going to make sure we read all annotations, all labels, all captions, all keys, all legends, and all notes. So it says note, figures not drawn to scale. Duh! So it says the area of rectangle Q is 18 centimeters squared. Okay, there's Q. We see it has, it doesn't matter which is the length or the width. Normally we work with the longer side, we call that the length, and the shorter side the width. So we have the length of 2x, a width of x, and it's telling us that somehow there's 18 centimeters squared. Okay. The perimeter of rectangle R is 30. So we have 2y on the length of R and y on the width of R. So there's a couple of things going on. We have x's, we have y's, we have things not drawn to scale, we have areas, and we have perimeters. That's a lot to keep track of. It's simple math, but it's still a lot to keep track of. I have a fan blowing on me, and I'm at death's door here. It is just so hot. So for Q, we have x and 2x. And it says the area of Q is equal to 18 centimeters squared. But we know the area normally is length times width. So we're going to get 2x times x. And that's equal to 2x squared. Okay? But we already know, since all these are the area of Q, that therefore 2x squared equals 18 centimeters squared. So we divide by 2, and we get x squared equals 9 centimeters squared, and we take the square root of both sides, so we get x equals 3 centimeters. So that means in our columns where we have A and B, this says x. So that means A is represented by 3. Okay? Now for the other rectangle, it gives us rectangle R, and it gives us 2y and y. And it says the perimeter of R equals 30 centimeters. Okay? So we know perimeter is equal to the length plus the width plus the length plus the width. There's a couple ways to do this. It's equal to 2 times the length plus the width. Right? Is one way to do it. All right? So the perimeter of R is equal to that. So the perimeter of R is equal to 2 times 2y plus y. So that's equal to 2 times 3y. And that's equal to 6y, if I did that right. And we also know from up here that 30 centimeters equals 6y. Divide both sides by 6, and we get 5 centimeters equals y. So we go back up here, y equals 5. So that means column B should be greater. Okay, so make sure you got your x's and the y's figured out. This one's about area, this one's about perimeter. Make sure you have your formulas correct. All right, there are other ways to do this. If we knew this was 30, we knew that 2x plus y equals 15, because we know it's just this and this. The perimeter is all 4 of them, so if we just add these two, it's half of it. So we still get 3y equals 15, and y equals 5. We still get y equals 5. Right? We probably could have solved this some other similar way to what I just said there, or maybe not. And there you have it. Okay, 21 is a good one. Maybe we'll end on 21. Let me see if anybody has any questions. Nope, no questions. Let's see, it's 5:29. Maybe you should even end here. I'm not sure. Do I have any scrap paper left? Let me see. Not too much. Let me see. I have so much extra paper here that I'm trying to avoid using blank paper, just wasting it. So we have A times B plus C, which is called the distributive property of multiplication. So it means A times B plus A times C, and there's a subtraction version of it as well. So A times B minus C is the same as AB minus AC. So we're using plus here. So it turns out that the distributive property is actually a subset of FOIL. Okay, so FOIL tells us if I have A plus B times C plus D, I get AC plus, right, first, outer, AD, plus inner, plus BC, plus BD. And often the two middle terms, when we're doing a polynomial, often they get added together. And in the real thing, we end up with x squared plus something x plus some constant. Okay? But technically, it doesn't have to be that, because we could have 1 plus 2 times 3 plus 4 and still work. You could argue 1 away, add the 1 plus 2 first and the 3 plus 4 and get 2 times 7. That works as well. So we're talking about this algebraically. Anyway, it turns out that the distributor property is actually a subset of FOIL. And the subset is if we have A plus 0 times B plus C. Because this is the same as AB plus 0B. Sorry, let me do it formally as a FOIL. AC plus 0B plus 0C. So we get AB plus AC. And that's what the rule is. So it turns out if we use 0, we're actually doing a FOIL. We're doing a shorthand of the FOIL. Okay? Now I'm mentioning all this because in this case, we don't have 1 versus 2 terms, and we don't have 2 terms versus 2 other terms. We actually have a longer case. We have a 1 plus 2 times a 3 plus 4 plus a 5. Okay? And if you follow how this works, we're basically what we're really doing is taking any term and multiplying it one at a time by all the other terms. Okay? So when we have more than, this is distributed. When it's this, it's FOIL. When we get to here, it's basically called the rainbow technique, where we're going to do this times each of these, and then this times each of these. And it doesn't matter how many terms is in each parenthesized group. We're just going to take every part of each parenthesized group and multiply it by everything else. All right? So with that in mind, if we bring the example up, and by the way, it's just as true whether there's a plus here or a minus. Just the same with the distributor property or the FOIL. The FOIL doesn't care what's plus or minus. It still works methodically in the same case. Okay? So let's try to bust this bugger down. So we have x minus y times x squared plus xy plus y squared. So what we need to do is rip this bugger apart. Okay? So we're going to take x, and each one at a time, we're going to multiply by that. So x times x squared is x cubed. X times xy squared is x squared y. X times y squared is x y squared. All right? And now we're going to take minus y and do the same thing. So, and I'm going to line these up in columns because at some point, if it's possible, we're going to combine like terms. So minus y times x is minus x squared y. So we have minus x squared y. We have minus y x squared, right, which is the same as this. If you want, I could write it the same way, just so we know what we're talking about. Right, x squared and y is still the same. Okay, so we multiplied this by the first term. Now we have minus y times this, so we get minus x y squared. Yes? And now we have minus y times plus y squared, so we get minus y cubed. And we're done. So when we combine like terms, we have a plus x squared y. This cancels out. We have a plus xy squared minus xy squared. That cancels out. And we end up with x cubed minus y cubed, which seems to imply that they're equal. 21 should be C. Yes. Yes, sir. So this is a nasty problem again. This is one of those ones. Again, you have a minute and a half to do this, and and I write sloppy. Sometimes I write X's like this. So it's hard to keep track of that. They probably instead of calling this A and B, they called it XY on purpose. And you have to be observant here that x squared y is the same as y x squared, and so on and so on and so on. And even if they called it A and B, this is one of those things where you have to make sure your attention to detail is really there, or you're going to get the answer wrong. And in fact, that you ended up with something weird like x squared minus y to the third, or x to the fourth minus y squared, how do you even compare that to x squared, x third minus y third, which is in B? So a lot of kids would probably put down D if you remember the rules of this thing. A lot of you might put down it cannot be determined. So this is one of those ones where you want to write everything down and you want to, do your rainbow technique. Just take it one at a time. Remember the minus signs. They're the death of anybody taking a standard test. Remember your minus signs. Okay, let me see if we should end it out here. Okay, 22 is actually an evolved problem, so we'll skip that to next time, and let's do 23. 23 is easy enough. So 23, we're going to look at the illustration. Oh yeah. We have an XY coordinate. It tells us that. We have two lines. Here's our center. One kind of goes below it, and it's called K. And one kind of goes above the center like that, and that's called J. They look like they're parallel. So are we going to ask ourselves, parallel, yes or no? Okay. And I'm going to note that the slope of this is positive, and the slope of that is positive. Okay. A negative slope goes like this, or this, or this, or this. Just some way this way. This is a minus slope. If we have an XY, a slope like this is positive. Okay, no matter where it is. It can be above the x-axis, above the 0, 0 point, below it. Okay, same here. It could be above or below it. So this is negative slope. This is positive slope. We don't know what the slope is in any of these, and we don't know it here. But we know it's a positive slope because it goes that way. Okay, there's a couple ways to memorize this. I have a rule of one that I like to apply to many things. Instead of memorizing both things, I only memorize that a positive slope looks this way. That way, if it's a negative slope, it's not this way. It's something going that way. All right? So I beat the illustration to death. There's nothing more it could tell me, except I know one is below the center and one is above the center. Okay? So now let's see if it really tells us the parallel or not. So it says line J, this line here, is the graph of y equals 3x plus 4. So we have a confirmation here because y equals mx plus b. If m is positive, then it's a positive slope. So we've confirmed that by them giving us that formula. So even if you can't remember, now you do. And by the way, if there's any other slope question on the test, you've just clued yourself into how to memorize that. That this is a positive slope, and if you can't remember, go back to this example. So this is a test-taking skill that often you can answer a question by looking at another question, or vice versa. Or it is confirmed that you did the right thing, even without it saying it. It's telling you here that this is a positive slope. So you're getting feedback on information. If you can't remember which way it goes, now you know. Okay? Line J is parallel to line K. So if line J is parallel to line K, that means K is also parallel to J. So two parallel lines have the same slope. So the slope of this is plus 3, and the slope of that is plus 3. Okay? So then it says column A, the slope of line K. We already know it's plus 3. And column B says the slope is minus 3. So A has to be the answer for 23. It's got to be. It's got to be. Life or death situation. It's got to be. Right? Okay, 24 is a little nastier. How about we end here? And because there's still a lot of parts to this left. And let me see if anybody has any questions. All right, I'm about to die. I'm going to drink something. I'm probably going to fire up another Ask Me Anything stream because I have a bunch of work to do, and it'll just work through there. Please like and subscribe to this. I'm doing a lot of work here for you guys, and it would be great if you guys could reciprocate back by giving the videos a like, subscribing to my channel, looking through my other videos, and let's just go for this. Again, I'm Greg at GregsTutoringNYC at gmail.com. I do private tutoring on all these tests. Please contact me with any questions you have. Peace out, brothers and sisters.